Welcome to the world of physics. When we first started this class, we discovered that physics is used so often in our daily lives. We discovered that physics is all around us. For instance, forensic scientists use physics to solve the whodunit mystery. Kinematics helps them determine the trajectory of a bullet. This is made possible by using Newton's law of motion. From this law, forensic scientists can determine what angle a gun was held when the shot was made. They can even tell if the person shot their self. Kinematics can also help determine who was at fault in a vehicular accident, how hard a car was hit, and the skid marks on the road can tell the forensic scientist how fast the person was going. Forensic scientists also use something called fluid dynamics. Fluid dynamics is when the scientists study the blood stain patterns, how the blood lands on the wall, tells what kind of weapon was used. It can even tell if the body was moved to manipulate the crime scene. This reminds me of one of my all-time favorite TV series called Dexter, about a blood spatter analyst. Let's look at where physics can bring us in the near future. So, a researcher at the Massachusetts Institute of Technology has discovered how to make a laser transmit an audible message to someone from across the room. This can be made possible by using the photoacoustics method and the sound transmission method. The sound is created by using water vapors in the air to absorb light, then transforming it to the sound in the air, which is called photoacoustics, and from that, sound reaches the ear. Cool inventions using lasers to create sound are made possible due to the physicist named Galileo. Galileo is one of the key figures of scientific revolution. He formed the principle of inertia, which states a body moving on a level surface will continue in the same direction at a constant speed unless disturbed. How did Galileo come up with this notion? One might ask. Well, he did so by doing the balls on ramps experiment. Doing this experiment, he discovered three things. One, objects slow down as they move up the ramp. Two, objects accelerate as they move down the ramp. And three, objects keep the same speed as they roll along a flat surface. Inertia was first introduced by Galileo, but Sir Isaac Newton restated Galileo's idea as his first law of motion. Every object continues in its state of rest or uniform motion in a straight line unless it is compelled to change that state by forces impressed upon it. The famous saying, "To every action there is a reaction," is the principle of action. Is the principle of action and reaction, or the rocket law. Let's look at boxing to understand it a little bit better. If we take two boxers, A and B, and place them in a ring, boxer A punches boxer B in the face. Naturally, boxer B will go down. Boxer B goes down because for every action force, there is an equal reaction force in the opposite direction. Another discovery in the physics world is electromagnetism. Without electromagnetism, we wouldn't have the amazing technological advancements that we have today. There are 7 types of electromagnetic waves: radio waves, infrared waves, ultraviolet waves, X-rays, and gamma rays. If we take a quick peek into these different waves, we learn that radio waves, microwaves, visible waves, and X-rays are all the same phenomenon, but have different wavelengths. Radio waves have longer wavelengths with lower energy and can travel long distance in the Earth's atmosphere and are very useful for communication. These different types of waves made things like watching television, listening to the radio, utilizing Wi-Fi, and accessing the GPS all possible. Before James Clerk Maxwell discovered that light is only a small part of the electromagnetic spectrum, physics was considered to be disconnected. Without Maxwell's contribution, our understanding of the nature of light would still be very limited. I guess you can kind of say James Clerk Maxwell shunned the light on physics. We can't give credit to the physicist without mentioning the great Albert Einstein. Einstein is most famously known for his equation E equals mc squared. This states that anything having mass has an equivalent amount of energy and vice versa. Einstein is also known for his theory of special relativity. The theory of special relativity explains how space and time are linked for objects that are moving at a constant speed in a straight line. One of its most famous aspects concerns objects moving at the speed of light. As the object approaches the speed of light, its mass becomes infinite and it is unable to go any faster than light travels. Einstein spent 10 years trying to include acceleration into this theory. And then he was able to publish the theory of general relativity in 1915. In this theory, he determined that massive objects cause a distortion in space-time, which is felt as gravity. To understand this better, imagine two objects exert a force of action on one another, known as gravity. Newton quantified the gravity between two objects when he formulated his three laws of motion. The force tugging between two bodies depends on how massive each one is and how far apart the two lie. Even as the center of the earth is pulling you towards it, you be firmly lodged on the ground. Your center of mass is pulling back on the earth. But the more massive body barely feels the tug from you, while with your much smaller mass, you find yourself firmly rooted, thanks to the same force. As we can see, the study of physics has resulted in a number of technological developments in the world, in medicine and quantum mechanics. There are quite a few instances when quantum mechanics are used. The one that stands out to me is lithotripsy. The medical term for it is shock wave lithotripsy, or SWL. It is more commonly used for kidney stones. Shock waves from outside the body are targeted at a kidney stone, causing the stone to fragment. The stones are broken into tiny pieces along the body, allowing the body to pass them in the urine. I actually had to have SWL done about 14 years ago when I had a kidney stone that was the size of a golf ball. The doctor said that the best way to describe SWL is to think of a giant boombox being placed on your back, turning the volume up extremely loud, and then using the sound waves to blast the stones. Well, I've said it once and I'll say it again. Physics is cool.